Exercise 9a, question 15. So we are given this a square and angle CED is obtuse. So we essentially want to find the area of the shaded region, which is another triangle. That's triangle ABE. Right. So in order to find that area, we can first start by triangle EDC, and that's because there are some things that we can do actually in this triangle. And that's because we are given this part of angle D, which is 40 degrees. So therefore, here is 90 minus 40, which is 50 degrees, because this is a square and it's a right angle. So in this triangle, we have this angle, which is 50 degrees, and we have this side length as well. So also another fact is that DC is also 10 centimeters because this is a square. This is a square. So now that we have basically three components, we can then use the sine rule to find this angle here. So angle CED. So therefore, we have sine E over 10 is equal to sine 50 over 8. So we just need to rearrange this and find the value of E. So after taking the sine inverse, we get two values actually, and that's property of sine. So but only one of them is going to be acceptable. So the first value is 73.2 and the second value that we get is 106.7 0.8 actually, to four significant figures. However, the important thing here is that, as we are told in the question, angle CED is obtuse, so therefore we accept this value. And now that we have the angle E, actually the basically the more accurate version of that without rounding is equal to 106.753 and 14 here. So that's the value of this, the size of angle CED. Now we have CED, we have this part of D, so we can simply find angle C, which is equal to 180 minus the sum of the above angles. So 106.7 plus 50. And angle ECD is equal to 23.25 degrees. Okay. Now here we need to use a very smart trick. So one possible way of solving is that we can, because this is the height, right? This is the height to this triangle, and also this is the height to the shaded triangle, and we know that it's perpendicular, it makes 90 degrees here. So by knowing that fact, we can use trigonometry to find the value of this height actually, so the value of the height of the triangle CED, because we have enough information to do that. Once we know this height, then we can also find the other height very simply. And if you have this height, then finding the area of the shaded triangle is very simple because we already know the base of that. So to find this height, remember that let's call the height h. So we can simply say that sine c, which is this angle, is equal to height over the hypotenuse, which is 8. So, and that's it. Because again, we know angle c, by the way. I mean angle well, ECD basically. So we have the value, which is 23.25. So we have 8 times 23.25. And now, so the value of the height is equal to 3.1575 centimeters. Now we can find the height of the shaded triangle. So to find that, we just do 10 minus this value, right? That's because this length is 10 centimeters, so the height in this case is also equal to that. Right, so to find the other height, we just do 10 minus this value, and it's equal to 6.84 centimeters. And we are almost done. So now that we have the height of the shaded triangle, so we just do half times the height times the base, and that gives us 34.2 centimeters squared for the area of the shaded triangle.